We end this module on the same paper from the late 50s we started with. Building on the work of Axel Thue, Alan Turing, and Emil Post, amongst others, Noam Chomsky provided a measuring stick for language grammars that met a minimal limit of expressiveness. No matter its eventual fate in describing natural languages, Chomsky's work became hugely influential for computer language theory. We have met so far three families of languages: the regular languages, the context-free languages, and those that are beyond context-free. In this video, we will talk about the strict containment relation captured by this Venn diagram. Every regular language is context-free, and every context-free language is in beyond context-free. But there are some beyond context-free languages that are not context-free, such as the so-called copy language we saw in the previous video. And then there are some context-free languages that are not regular, such as the so-called mirror language of palindromes. For the sake of symmetry, let us include a similar example of a regular language, the so-called star language. Here's another set of languages that illustrate this hierarchy. This is part of what Chomsky had proposed as his hierarchy of languages. There were more layers to his scheme that are yet to be explored by us. Next week, we will foray into recursively enumerable languages, which are the set of all languages that can be recognized by a Turing machine. In fact, it can be shown that any kind of formal algorithmic procedure that can be precisely defined can be expressed as a recursively enumerable language. The RE class is the ceiling of formal languages. Each level of the hierarchy has its own methods to recognize and generate languages. The regular languages can be recognized by DFAs and NFAs, and they can be generated by regular expressions. The context-free languages can be recognized by PDAs, and they can be generated by CFGs. We have also seen that the recognizers are equivalent to the generators in each level. So, for example, any language that can be recognized by a DFA can be generated by a regular expression and vice versa. Bear in mind that the recognizers and generators of a higher level are also valid for all lower levels. Each level is strictly contained in the one above. Hence, there exist CFGs and PDAs for all regular languages too. In terms of historical development, the class of recursively enumerable languages were the first ones to be written about formally. It was Turing and his computing machines that could recognize this most general class of languages. He proved that all problems that could be solved using computers, or equivalently all formal languages that could be recognized, could be done so using his computing machines. So is there a language that can be recognized on any computer? Turing came up with an incredibly simple problem called the halting problem, which was provably outside the realm of computability. So there was this really big bounded class of languages, and then in the 50s, it was asked, could we break it down further? For example, are the set of all languages that require no memory and just the input special in some way? Turns out they were, and so on and so forth. Several more language families were invented. We have studied the genesis in reverse, starting from a very simple class of languages called regular languages and building up to the class of all recognizable languages that will be the subject of discussion in the remainder of this course.